Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking for a 0.18 micrometer process technology for which TOX, that's oxide thickness, that is equal to 4 nanometer, and mu(n) is equal to 450 centimeter square per voltage second. Find COX, that's oxide capacitance. So we have to find this one, and Kn prime, that's transconductance parameter, and the overdrive voltage VOV required to operate the transistor having W over L is equal to 20 in saturation with ID, that's drain current, that's equal to 0.3 milliampere. Here they are asking to find out the COX, Kn prime and VOV, and also what is the minimum value of VDS needed, drain source voltage also, right? So the required things are COX, Kn prime, VOV and VDS. Now let's start with COX. To find out the COX, we just try to use this equation, that is epsilon OX over TOX. Epsilon OX is oxide, like silicon oxide permittivity, and then TOX is oxide thickness. This one is a constant number. This is going to remain the same for everything, like this is always the same value, fixed number. That's going to be 3.45 times 10 to the power of minus 11, and then oxide thickness TOX, that's equal to 4 nanometer, 4 times 10 to the power of minus 9. Okay, that's going to give us 8.6 times 10 to the power of minus 3 farad per meter square. And here we can write this one in terms of femto per micrometer square, like whenever we have, okay, let's write this one. Femto is 10 to the power of minus 15. When we write micrometer square, this doesn't mean just meter square, it's micrometer square. Like we know that micro is 10 to the power of minus 6. If you square that one, that's going to be 10 to the power of minus 12, right? That's what this one means. Now here, if we write this one in terms of femto micrometer square, because usually it's given like that, if we write this one in terms of that, this is going to be 8.6 femto, that's 10 to the power of minus 15 farad per micrometer square. So this is going to be the COX value, oxide capacitance. Okay, now the next thing is we have to find out Kn prime, that's transconductance parameter. That can be calculated using mu(n) COX. Here we have the mu(n) provided, 450 centimeter square per voltage second. 450 centimeter square. I am converting this centimeter square into meter square. Okay, again this centimeter square, not only meter square, like we know that when we have centimeter square, it means the whole centimeter square. So in order to convert this one into meter square, we just have to multiply this one by 10 to the power of minus 4. Now this is going to become meter square divided by voltage second. And then here we already have this one in terms of meter square. I am picking up the first one. That's 8.6 times 10 to the power of minus, that's COX. Okay, COX, we calculated COX, 8.6 times 10 to the power of minus 3 farad per meter square. From here you can see this meter square cancels, and if you multiply and calculate this one, you're going to get 387 times 10 to the power of minus 6 amperes per voltage square. 10 to the power of minus 6 is micro, so this is going to be 387 micro ampere per voltage square. This is our Kn prime. Now the next thing is we have to find out the overdrive voltage, that is VOV, and in that situation we have WL provided, and also we have the drain current. Now we can derive this VOV using drain current equation, that's given by ID is equal to half Kn prime times W over L times VGS minus VT whole square. Okay, now here we are interested in finding VOV. Now VGS minus VT is equal to VOV. So instead of writing like this, we can also write this one as ID times half Kn prime W over L. Instead of VGS minus VT, we can replace that one with VOV square. Okay, because VGS minus VT is equal to VOV. Now from this one we are going to rearrange this equation and bring an equation for VOV. VOV is going to be, if I bring this 2 to this side, it's going to be 2ID divided by Kn prime divided by W over L, right? So this is going to be what? 2 times ID is given 0.3 milliamperes, 0.3 times 10 to the power of minus 3 ampere divided by the trans conductance, that is 387 times 10 to the power of minus 6 times W over L. W over L is equal to this one, 20. Okay, after you calculate this one, you're going to get, let's continue here. After you calculate this one, you are going to get VOV is equal to 0.278, and all of them have, I forgot to put one thing, square root. So when you do that, you will get 0.278 voltage, and that's approximately equal to 0.28 voltage. Okay, so this is the VOV. Now the next thing is, what is the minimum value of VDS needed? Now here we have a saturation region. In saturation region, VDS minimum is equal to VOV, and we already found out VOV, that is 0.28 voltage. So that's going to be the same voltage we are going to have for VDS. And that's it for this question. That's all we need, right? I hope this helps. Thanks for watching.